Alright, boys and girls, we're back to do video notes 2, or video notes 10 part 2, which is solving multiplication and addition inequalities, or multiplying and dividing inequalities. Now we're going to start this video off with a little investigation of properties. So I'm going to do number 1 with you to get it set up for you. Then you're going to make an observation based off of what I just set up with you. That should help you to, kind of understand or figure out what's going to be going on. Okay, it says consider the inequality 4 is greater than 1. Is this true? You should have answered yes. So now what it's telling us to do is to multiply each statement at the right by 3 through negative 3. So that means 3, 2, 1, 0, negative 1, negative 2, negative 3. And it says to do that on both sides. So therefore, that means I'm going to multiply all of these by 3 through negative 3. And I'm going to multiply all of these by 3 through negative 3. Then it says we're going to complete the statement by writing less than, equal to, or greater than in the box. Okay, so first, let's do what it says. And multiply everything by 3 through negative 3. So that means on this side, I'm going to multiply by 3. On this side, I'm going to multiply by 3. Next one, I'm going to multiply by 2. Other side, multiply by 2. Next will be 1. Next will be 0. Next will be negative 1. Next will be negative 2. And next, the last will be negative 3. Just keep in mind, parentheses means we're going to multiply. Okay, so now let's multiply it out and let's fill in our inequality symbols. Okay, 4 times 3 is 12. 1 times 3 is 3. So is 12 less than, equal to, or greater than 3? It's greater than. Okay, 4 times 2 is 8. 1 times 2 is 2. 8 is greater than 2. 4 times 1 is 4. 1 times 1 is 1. 4 is greater than 1. 4 times 0 is 0. 1 times 0 is 0. 0 is equal to 0. Pretty sure some of y'all ready to keep writing greater than in there. You just was on a roll. Slow your roll. Okay, 4 times negative 1 is negative 4. 1 times negative 1 is negative 1. So are we going to have less than, equal to, or greater than? Keep in mind that we have negative numbers, and negatives are opposite of your positives. So if a positive 4 is greater than a positive 1, then that would mean a negative 4 is less than a negative 1. Because remember, the more you go into your negatives, the smaller you get. It's like going down into a hole. The bigger the number looks means the deeper you're going. So you're actually lower or smaller. Okay, 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. So negative 8 is less than negative 2. And 4 times negative 3 is negative 12. 1 times negative 3 is negative 3. So negative 12 is less than negative 3. Okay, now I want you to pause the video, and I want you to look at what was going on inside of our table here and answer the questions numbers 2, 3, and 4, and see if you can figure out basically what we're about to be doing. What is going to be kind of different here. So go ahead and pause your video and answer 2, 3, and 4. Okay. We'll look at that and we'll talk about it in class to see if your conclusions were correct. Now let's go ahead and talk about our multiplication property of inequality. Okay, we have a property for c is greater than 0. We also have a property for c is less than 0. So let's start up here. So if it says that c is greater than 0, that means that c is positive. Because greater than 0 has to be 1, 2, 3, 4, and so on. So those are all positive numbers. So our property states that if a is greater than b, then a times c is going to be greater than b times c. And if a is less than b, then a times c is going to be less than b times c. So let's go ahead and plug in some values. So I'm plugging in 15 for a, 10 for b. I'm going to write it like this time so that maybe it will help you to really realize what's going on. You can see the substitution easier. So if 15 is greater than 10, then 15 times 2, which is 30, should be greater than 10 times 2, which is 20. Is that true? Yes, it is. So we do put a greater than symbol in there, and it does check to be true. Okay, let's do the other side with less than symbols. If 3 is less than 7, which we know it is, then that means that 3 times 2, which is 6, should be less than 7 times 2, which is 14. Is 6 less than 14? Of course. So that checks to be true. So basically that goes back to what we were doing with equations. If I multiply the same thing by both sides, it's pretty much going to stay balanced. Okay, now let's look at our inequality property when c is less than 0. So if c is less than 0, then that means c has to be a negative number. So c less than 0 means c's got to be negative 1, negative 2, negative 3, and so on. So all of those negatives. So it says if a is greater than b, then a times c is less than b times c. And if a is less than b, then a times c is greater than b times c. Now you may be thinking, well, that's the same thing we just did. But pay close attention. You should notice that something did change from c is greater than 0 to c is less than 0. So let's go through an example so that we can see exactly what changed. What has happened here? So I plugged in 10 for A and 4 for B. My C is negative 2. So it says if 10 is greater than 4, then 10 times negative 2 should be less than 4 times negative 2. Let's check to see is that true. 10 times negative 2 is negative 20. 4 times negative 2 is negative 8. Is negative 20 greater than or less than negative 8? Remember, negatives are opposite, so the 20 in a negative is less than the 8 in a negative. If 4 is less than 8, then 4 times negative 2 should be greater than 8 times negative 2. So let's check to see if it's true. 4 times negative 2 is negative 8. 8 times negative 2 is negative 16. A negative 8 is greater than a negative 16. So therefore, both of these have checked to be true. Now, as we were doing that, did you notice what was happening? Let's go back and take a look. Notice all of our symbols up here. We have less than. We have greater than right here. We have greater than right here. When I come to the other side, I have less than, and then I have less than over here. So C is greater than 0. When I come down here for C is less than 0, notice I started with the greater than symbol, but then it should end up being less than once I solve. Same as if I started with the less than symbol. Once I solved, it should be greater than. So notice up here, We had the same symbol. Make sure you're moving back up towards C is positive. So they're the same. But notice that when I move to C is less than 0, my symbols flipped or reversed. Greater than here, less than here. So that is flipped. Same over here. I started with greater than, I'm sorry, less than, and the solution would have to be greater than. So that is also flipped. Okay, and it says that these properties are also true for less than or equal to and greater than or equal to symbols. So that's very important. So remember, it doesn't matter which inequality symbol you have, this is going to be true. So basically, what you should have noticed is that if I am multiplying by a negative number, I'm going to flip or reverse the inequality symbol. And that's exactly what just happened. So notice, C was what was being multiplied each time, and in this case, C was a negative number. So since we multiplied by a negative number, then that ended up making our inequality flip or reverse to the opposite direction. So please keep that in mind. That is the only difference between solving equations and solving inequalities. Is if that you multiply by a negative, you need to flip your symbol. Okay, let's turn to page 44 and do some examples. Okay, it says we're going to solve and graph. So they have split it up for you into multiplying by a positive number and multiplying by a negative number. And that's just so that you can see the difference and really see what's going on. Okay, so remember that when we solve, we're solving exactly like we did equations. We're going to use inverse operations. So that means since this says x divided by 2 is less than negative 1, then it means what I'm going to do for step 1 is I'm going to multiply both sides. And since I'm just writing down what I'm doing for this one, in this case, I'm going to multiply both sides by 2. So the way that this looks is, remember, we can put these in parentheses and we can put a 2 outside of it. That shows that we're multiplying both sides by 2. So now our 2's will cancel on the left side, leaving me with my variable isolated. So x is less than negative 2. And to graph it, remember I put negative 2 in the middle and fill in numbers on both sides. And since we don't have an an equal to part, our circle is going to remain open and it's going to go to the left. Okay, let's do B. We are still multiplying by a positive. So in this problem, which you're probably not going to have, I'm just going to go ahead and show you how to do it. Okay, what we're actually going to have to do is multiply by the reciprocal to get n by itself. And technically, that's exactly what we did over here, because this is basically x over 2 is like 1/2 x. So your fraction is 1 over 2. Well, if I want to make this 2 by itself, a fraction, wouldn't it be 2 over 1? So that is the reciprocal. So remember, a reciprocal is a flipped fraction. So therefore, if I want to solve b over here, I need to multiply by the reciprocal. So therefore, I'm going to put both sides in parentheses. And I'm going to flip flip my fraction in front of the variable. So therefore, I'm going to multiply by 5/2. And remember, whatever we do to one side, we do the same thing to the other. So we multiply the other by 5/2. Now in this situation, keep in mind we're multiplying straight across. So 5 times 2 is 10. 2 times 5 is 10. Doesn't 10 over 10 equal 1? So that's what causes these to cancel out, leaving me with my variable isolated. Now I'm going to have to solve this other side. So remember when we solve fractions or multiply fractions, you put your whole number over 1. Then we're going to rewrite the other. So since 4 times 5 is 20, 1 times 2 is 2. 20 divided by 2 equals 10. So therefore, n is greater than or equal to 10. Let's not remember to box our solutions. Okay, now graph. Put 10 in the middle. And just because it's kind of small, I'm going to go ahead and skip this, which you should know is 11. So that means this is going to be 12. That would be 13. In front of 10 would be 9. So that means this one would be 8. That would be 7. Okay, we know we need a circle at 10. It's going to go to the right. Now this time, since we have the equal to parts, we've got to fill in our circle. So there's your graph. Okay, now let's look at if we have a negative number. So multiplying by a negative number. Now keep in mind we're going to solve just like an equation. So the first thing we're doing, I'm just going to write the steps for this problem. So since I have 3 in the denominator, and remember in your equations video, I told you if that negative sign is in front of your division bar, just take it and place it on your number. So I'm just going to cross that out as it goes there. So technically it's like having a -3. So what I would have to do is multiply both sides by -3. Because remember, it is whatever is attached to that variable. So since -3 is attached to my variable, I'm going to put both sides in parentheses and put -3 outside of my parentheses to show my multiplication. If you need to, put that in parentheses also. So now remember, these -3's are going to cancel, leaving me with x is less. Oh, wait a minute. We multiplied by a negative variable. So remember, a negative number. So remember it said that whenever I multiply by a negative, I need to reverse or flip my symbol. So step 2 is going to be flip the symbol. So now instead of x being, instead of it being less than, we should have greater than, because this is negative. So -4 times -3 is 12. And if you plug in 12 back into your original problem, you would have, excuse me, 12 divided by -3, which is -4. So basically, okay, I'm sorry. I had to pause it for a second because I started confusing myself. Remember, we're doing inequalities, not equations. So that means I would have to plug in something greater than 12, such as 13 or 14. So let's do something like 15. So if I plugged in 15 for my x, because it's greater than 12, then if I do 15 divided by -3, I would get -5. So I would have -5 over here, and remember that's a positive 12. So -5 is less than your positive 12. So that inequality would be true. So if I did a positive, then that means that would be negative. So if I would have plugged in some negative value or something that was, greater than or less than -12, then that means I wouldn't have gotten a true inequality. Okay, let's graph. Put 12 in the middle. That's 11. So that's 13. That's 14. That's 11. That's 10. We need a circle at 12. It's going to the right. No equal to part, so it remains open. Okay, even though I don't really think you have things like this until 8th grade, but we're going to go ahead and go over it very quickly. So, since we have -2/3, remember, take your negative and just put it on either number. But remember, we have to multiply by the reciprocal of the number. So therefore, I'm going to multiply both sides by -3/2. So these are going to cancel, leaving me with n. Remember, we multiplied by a negative. Reverse your symbol. So it should be less than or equal to now. And multiply this out. So write your 4 over 1. And we're multiplying it by -3/2. So remember, whenever you multiply a positive by a negative, you're going to get a negative. And let's just go ahead and multiply. 4 times 3 is 12. 1 times 2 is 2. 12 divided by 2 is 6. So that's a -6. And let's box both of those solutions. Now let's graph. -6 goes in the middle. That's -5. That's -4. That's -3. So this is -7. This would be -8, -9, so on. So we need a circle at 6. It's going to the left. And since we have the equal to part, close your circle in. Okay, that sums up our video notes 10, part 2. You have your understanding check practice problems that you need to complete and come in ready for us to go over and check homework. Please don't forget, write down any questions on a post-it note and post it on the parking lot as you enter the room so that we can discuss that during class on Monday. All right, guys, have a great weekend, and I'll see you Monday. Bye-bye. Love you.